In the heart of the ancient world, the city of Alexandria stood as a beacon of knowledge and intellectual pursuit. Founded by Alexander the Great, it quickly became the epicenter of Hellenistic culture and scholarship. At its core was the legendary Great Library, a repository of scrolls containing the accumulated wisdom of civilizations. Within this vibrant intellectual ecosystem, a figure of immense importance emerged, known to history as Euclid. Yet, the man himself remains a profound enigma, a ghost in the annals of history. No definitive biography of Euclid was ever written in antiquity, leaving his life story shrouded in speculation. We know him almost exclusively through a single, monumental work, the Elements. This treatise, compiled around 300 BCE, would become the blueprint for the entire field of geometry. The Elements is not a work of entirely original discovery, but rather a masterful synthesis. Euclid gathered the disparate geometric knowledge of previous Greek mathematicians like Thales, Pythagoras, and Eudoxus. His true genius lay in organizing this knowledge into a single, coherent, and logically rigorous framework. The work is divided into 13 books, each building upon the last with meticulous precision. It begins not with shapes, but with the very foundation of logical argument. Euclid lays down 23 definitions, establishing a common vocabulary for his geometric universe. A point, he states, is that which has no part. A line is breadthless length. These simple, abstract statements form the bedrock of everything that follows. Following the definitions, Euclid presents his 5 famous postulates. These are the assumed truths of his system, the rules of the game that require no proof. The first postulate allows for the drawing of a straight line between any 2 points. The second allows for the extension of a finite straight line continuously in a straight line. The third describes the construction of a circle with any center and radius. The fourth states that all right angles are equal to one another. The fifth, the parallel postulate, is the most complex and famous of all. It essentially states that if 2 lines are crossed by a third, and the interior angles on one side are less than 2 right angles, the 2 lines will eventually meet on that side. This particular postulate haunted mathematicians for over 2 millennia. Many tried to prove it from the other 4, believing it to be a theorem rather than a necessary assumption. Their failures ultimately led to the discovery of non-Euclidean geometries in the 19th century. Alongside the postulates are the 5 common notions, or axioms, that apply to all sciences. Things which are equal to the same thing are also equal to one another. If equals be added to equals, the wholes are equal. The whole is greater than the part. With this logical toolkit in place, Euclid begins his monumental task of proof. Rest of the Elements consists of 465 propositions, each one a theorem proven with rigorous, step-by-step logic. Each proof relies only on the initial axioms and propositions that have been previously proven. This creates an unbreakable chain of reasoning from the simplest assumptions to the most complex conclusions. Book I covers basic plane geometry, culminating in the famous Pythagorean theorem. Euclid's proof of this theorem is a masterpiece of deductive logic, different from the visual proofs often used today. Books the 2nd and 3 deal with what we would now call geometric algebra and circle geometry. He explores the properties of tangents, secants, and the relationships between angles and arcs in a circle. Book 4 is concerned with the construction of regular polygons, inscribed within or circumscribed about circles. Books 5 and 6 introduce the theory of proportions, a brilliant way to handle irrational numbers geometrically. This work, attributed to Eudoxus, allowed Greek mathematics to deal with concepts like the square root of 2 without a decimal system. Book 7 to 8, and X pivot from geometry to number theory. Here, Euclid defines prime numbers, composite numbers, and perfect numbers. This section contains the Euclidean algorithm for finding the greatest common divisor of two numbers. It also features the famous proof that there are infinitely many prime numbers. Book X is a complex and subtle classification of incommensurable magnitudes, or irrational numbers. The final three books, Vitatuamen, Sionadovstabiamen Supernatural, and 30, extend the principles of the earlier books into three-dimensional solid geometry. They deal with the properties of planes, solid angles, and polyhedra. The Elements culminates with the construction of the 5 Platonic solids. These are the only 5 convex regular polyhedra that can exist. The influence of the Elements on human thought can scarcely be overstated. For over 2,000 years, it was the primary textbook for mathematics education. It was considered an essential part of a liberal arts education, the pinnacle of logical training. The book was preserved and studied by Islamic scholars during Europe's Dark Ages. These Arabic translations were later instrumental in reintroducing Euclid to Europe during the Renaissance. The invention of the printing press. The Elements was one of the very first mathematical works to be printed. The first printed edition appeared in Venice in 1482, ensuring its wide dissemination. This accessibility cemented its status as the definitive foundation of mathematics. Its axiomatic method became the model for rational thought itself. Philosophers like Baruch, Spinoza structured his ethics in a Euclidean, axiomatic format. Scientific pioneers were deeply indebted to Euclid's work. Nicolaus Copernicus used Euclidean geometry to model the motions of the planets. Johannes Kepler relied on its principles to derive his laws of planetary motion. Galileo Galilei famously stated that the universe is written in the language of mathematics, with triangles and circles as its letters. Isaac Newton's Principia Mathematica, the foundation of classical physics, was built upon a Euclidean framework. Newton used geometric proofs in the style of Euclid to describe his laws of motion and universal gravitation. The influence extended even to politics and statecraft. Abraham Lincoln, as a young man, studied the elements by firelight to hone his logical reasoning. He credited Euclid with teaching him the meaning of the word demonstrate. This logical precision is evident in the powerful and structured rhetoric of his speeches, like the Gettysburg Address. In the 19th century, the absolute authority of Euclidean geometry was finally challenged. Mathematicians like Boryai, Lobachevsky, and Riemann created consistent geometries by negating the parallel postulate. This revolution in thought did not diminish Euclid's achievement. Rather, it highlighted the power of his axiomatic method. It showed that by starting with different assumptions, one could build entirely new, self-consistent worlds. Albert Einstein's theory of general relativity would later use non-Euclidean geometry to describe the curvature of space-time. Even in a world of quantum mechanics and string theory, the Elements remains relevant. Its true legacy is not just the theorems themselves, but the very idea of mathematical proof. The Elements taught the world how to move from unquestionable truths to complex certainties. It is a testament to the power of human reason to build magnificent, enduring structures of thought. While students today may learn geometry from modern textbooks, the spirit of Euclid is present in everyone. The logical, step-by-step progression is a direct inheritance from his ancient work. The structure of computer algorithms and programming languages is deeply rooted in the same deductive logic. Every if-then statement is a small echo of a Euclidean proposition. Euclid of Alexandria, the man we barely know, gave the world more than a book of geometry. He provided a blueprint for thinking, a universal language of reason. His Elements is not just a historical artifact. It is a living part of our intellectual heritage. It stands as one of the most significant and influential works ever written. The book's journey through time is a story of preservation and rediscovery. From papyrus scrolls in Alexandria to vellum codices in Byzantium Tartagopiot, from Arabic translations in Baghdad to the printing presses of Renaissance Europe, the Elements has proven to be as durable as the logical principles it contains. It demonstrates that the most powerful ideas are often the most clearly structured. Euclid's system was so successful, it became known simply as geometry. For centuries, no other kind of geometry was considered possible. This dominance is a testament to its completeness and internal consistency. The work is a model of clarity and pedagogical elegance. Euclid anticipates potential points of confusion and addresses them with precision. He never assumes knowledge that has not been established within the text itself. Self-contained nature made it the perfect tool for self-study. The first English translation by Sir Henry Billingsley in 1570 was a monumental publication. It featured a famous preface by the magician and scientist, John Dee. The edition also included innovative pop-up 3D diagrams to illustrate solid geometry. This shows a long history of trying to make the Elements accessible and engaging. The book's impact on aesthetics and art is also significant. Principles of proportion, symmetry, and geometric form are central to many artistic traditions. The golden ratio, explored by Euclid, has fascinated artists and architects for centuries. Euclid's work provided a rational basis for beauty. It suggested that the universe's structure is fundamentally mathematical and orderly. This idea, inherited from the Pythagoreans, was given its most robust expression by Euclid. Even the American Declaration of Independence echoes with Euclidean thought. The phrase, self-evident truths, is a direct parallel to Euclid's Axioms. It attempts to build a case for revolution based on a foundation of undeniable principles. Thus, the reach of the Elements extends from the classroom to the courtroom to the corridors of power. The mystery of the man Euclid only serves to enhance the legacy of his work. The content has eclipsed the creator. It is a work that belongs not to one man, but to all of humanity. Euclid's Elements is the quintessential example of how to build a world from ideas. It is a silent teacher, passionately waiting for new students for over 2,300 years. The book codifies the logic of space, but its method codifies the logic of thought. It is the foundation upon which the edifice of modern mathematics was constructed. From a handful of assumptions, an entire universe of certainty was born. The Elements is more than a history lesson. It is a masterclass in clarity. It teaches that the most complex problems can be broken down into simple, manageable steps. This problem-solving approach is one of its most valuable, our mathematical lessons. The work is a triumph of order over chaos. It imposes a logical grid upon the seemingly infinite possibilities of space. Euclid's voice, though silent for millennia, speaks through the unwavering logic of his proofs. His blueprint for geometry became a blueprint for reason itself. The simple tools of a straightedge and compass, in his hands, were enough to build a world. Legacy of the Elements is the enduring power of a good argument. It is the quiet confidence of a conclusion that has been rigorously demonstrated. From Alexandria, this blueprint of geometry spread to enlighten the entire globe. And its simple, powerful logic continues to shape our world today.